Hey scholars! Welcome to Mathora. I'm Ms. B, and you'll be learning with me. Today, you'll be watching the only video you need to understand integers. By the end of this lesson, you'll be able to identify and understand negative and positive numbers, apply integer rules to all operations, and avoid the most common Algebra EOC mistakes. First, we're going to tap into our prior knowledge. Then, we're going to get into the lesson. And after, I'm going to check to see how well you understood. Now let's talk about the basics. Think about the number line. You've seen it forever, even back in elementary school. 0 is right in the middle. To the right, the numbers go up like normal. To the left, the numbers also go up, but they're actually getting smaller. And that right there is where most people start getting confused. Let's make this real. Think about money. If you have negative $2, you owe a little bit of money. If you have negative $10, you owe a lot more money. Even though 10 is bigger than 2, negative 10 has less value. So on the number line, the farther you go left, the less you have. So what are integers? Integers are negative and positive numbers. But here's a quick note. 0 is not positive and it's not negative. It just sits right there in the middle, minding its business. Most mistakes with integers don't come from people being bad at math. They come from people not really understanding what's happening on the number line. So if we get this part, everything else gets easier. Now, before we add and subtract integers, which is where things usually get tricky, we're going to start with multiplying and dividing. Not because it's harder, but because it's actually easier and it helps us later. When it comes to multiplying and dividing integers, there are only two rules. If the signs are the same, the face is happy. Your answer is positive. If the signs are different, the face is sad. Your answer is negative. That's it. Same sign, positive. Different signs, negative. If you already feel good about multiplying and dividing integers, you can use the timestamps below and skip ahead. If not, stay with me. We're about to look at some examples. Let's start with example 1. Example 1. We have negative 6 times negative 4. The first thing I'm going to do is I'm going to multiply my numbers like normal. 6 times 4 equals 24. Now I need to determine the sign. And our rules say if we have the same sign, then it's going to be a happy face, which means positive results. And as you can see, we have a negative I and a negative I, so therefore our answer is going to be positive 24. As long as our smiley face is happy, our answer is happy. Example 2. Here we have negative 9 times 5. The first thing I'm going to do is multiply like normal. 9 times 5 is 45. Now I need to use a smiley face to determine what kind of sign I'm going to have at the end. I'm going to get a negative eyeball from our 9, and I'm going to get a positive eyeball from our 5, which means that's our sad face. Different signs, negative results. Negative 9 times 5 equals negative 45. Example 3. Here we have negative 72 divided by 9. The first thing we're going to do is divide like normal. 72 divided by 9 is 8. Now, let's use our smiley face to see if it's going to be a positive 8 or negative 8. We have a negative eyeball coming from 72 and a positive eyeball coming from 9. So therefore, negative 8 is going to be our final answer. Be sure to box it in. Example 4. We have negative 8 divided by a negative 56. Now this example is just to show you how different your integer equations could look. We're going to still divide like normal. 56 divided by 8 is going to be 7. Now we're going to determine if it's going to be a positive 7 or a negative 7. We're getting a negative eyeball from the 8, and then we're getting a negative eyeball from the 56. Happy face, happy results. Our answer is positive 7. Example 5, the hidden positive explained. I saved this for last right before we go into adding and subtracting because this is a skill you need to know. Let's rewrite this problem. What it really says is negative 1 times negative 45. Yes, it is an imaginary 1 there. So what we're going to do is use our multiplication integer rules. 45 times 1 is 45. Now, let's determine if it's going to be a negative or a positive. Using my smiley face, I'm getting a negative from the 1, and I'm also getting a negative from the 45. Here are my arrows. Forgot to write them. Same sign, positive results. So therefore, a happy face, a happy answer. This gives us positive 45. Whenever you see two operations side by side, be sure to use your multiplication integer rules. Check for understanding. Before we move forward, go ahead and choose the correct sign of the final answer without solving. Let's talk about it. The first one, we have a negative times a positive, so therefore, that's going to give me negative results. Now I know the answer choices are between B and C. For number 2, we have a negative divided by a negative, and that's going to give me positive results. And for number 3, we have a positive multiplied by a negative, so therefore that is going to give me negative results. Awesome job. Let's move on. Alright, now let's talk about adding and subtracting integers. This part is where most people start to overthink, but I promise it's not as bad as it looks. When you're adding and subtracting integers, you're really just doing one of two things. You're either adding numbers with the sign or adding numbers with different signs. Let that sink in. If the signs are the same, you add the numbers and keep the sign. If the signs are different, you subtract the numbers and keep the sign of the number with the greater value. That's the rule. But the rule only works if the problem is written clearly. So that brings me to my best tip. My best tip for adding and subtracting integers is rewrite the problem first. A lot of integer problems look hard because they look messy, not because they're actually difficult. Rewriting just means cleaning it up so your brain can really see what's going on. For example, negative 12 minus negative 7. Instead of trying to solve it this way, let's rewrite it first. So that's going to make negative 12 plus 7. And that's why we needed to know our multiplication rules before we started. That's the same problem, just written in a cleaner way. Anytime you see subtraction, especially subtraction of a negative, rewriting the problem is always going to save you. Jumping right into example 1, we have negative 15 plus parentheses negative 8. The first thing I'm going to do is rewrite this problem because I see a negative sign, a plus sign, and a negative sign. We only need two operations. So I'm going to do term by term. The first term we have is negative 15. Negative 15 is in the front, so therefore it gets to stay the same. Now I'm going to circle the positive sign and parentheses negative 8. Now here's why we needed to know our multiplication integer rules first. Outside of the parentheses is a 1. So that really says positive 1 times negative 8. So let's use our smiley face just to stay on track. We have a positive I coming from the 1, a negative I coming from the 8. So therefore we have a sad face, which means we are going to rewrite this problem as negative 15 minus 8. Now let's follow our adding and subtracting integer rules. Same sign, add and keep. So I'm going to add 15 to 8, and we're going to get 23. We added our two numbers. Now we need to keep the negative sign from both of the numbers. So therefore, our final answer is going to be negative 23. Example 2. In this example, we are not going to need to rewrite the problem because we only see two operations here. The first number we see is negative 42. I'm going to highlight that in red. The second number I have is a positive 17. I'm going to highlight that in green. So now I clearly see that I have two different signs. So we need to follow the rule of different signs, subtract the numbers, and keep the sign of the highest number. So 42 minus 17 is 25. And when I say keep the sign of the highest number, I mean literally between 42 and 17. So our final answer is going to be negative 25. We have more negatives than we have positives. Example 3, we have negative 30 minus negative 12. Now, I see 3 different negative signs, so we're definitely going to need to rewrite first. As always, the number in the front, as long as it's not in parentheses or anything, it gets to stay the same. So we have a negative 30, and therefore we're just going to rewrite negative 30. Now, I'm going to circle the negative sign and the negative 12. Remember our multiplication integer rules? There's a 1 right there, so we have a negative times a negative, and that's going to be a positive. So our new problem is going to say negative 30 plus 12. You see how that changes? That's why we need to rewrite the problem. Now I have 2 different signs, negative sign and a positive sign. So it says different signs, subtract, and pick the sign of the biggest number. 30 minus 12 is 18. We have more negatives than positives, so therefore our answer is also going to be negative. The final answer is negative 18. Be sure to box in your final answer. Example 4, 3 terms, and I have 3 things to say. First, we're going to be working in black and white. Second, always follow PEMDAS. And third, only work with 2 numbers at a time. So here, we're going to combine positive 6 and negative 14. Those are 2 different signs. So therefore, we're going to subtract. 14 minus 6 is going to give us 8. And now, we're going to keep the sign of the biggest number. Well, we have more negatives than positives, so that's going to be a negative 8. Now let's bring down the term that we did not use, negative 9. So we have negative 8 minus 9. The rule says same sign, add, and keep the sign. 8 plus 9 is going to be 17. And since they are both negative, our answer is going to stay negative. So our final answer to 6 minus 14 minus 9 is negative 17. Example 5, assessment style. Here we have negative 48 minus negative 16 plus 9. First thing we need to do is rewrite the problem. We have negative 48, and here you see in the middle 2 negative signs. So if we were to plug that into a smiley face, we would get a smiley face. So therefore those 2 negatives change into a positive sign. So it is plus 16 plus 9. Now, only using 2 numbers at a time, following PEMDAS, we're going to go ahead and use our integer rules. So here we have a negative number and a positive number. So different signs, subtract, and pick. 48 minus 16 is 32, and we have more negatives, so therefore it is going to be negative 32. Bring down your plus 9. Now, once again, we have a negative, and we also have a positive number. So we're going to subtract and pick the sign of the highest number. 32 minus 9 is going to be 23. And we have more negatives once again, so therefore our final answer is going to be negative 23. Check for understanding. Spot the mistake. Is the answer correct? Why or why not? The answer choice is B. No, they rewrote the problem wrong. 2 negatives would change it into a positive. And by it, I mean the negative 7 would have been plus 7. Alright scholars, that's today's lesson. If you feel better about integers now, like the video and subscribe for more Math Made Clear. Before you go, drop your exit ticket in the comments.